对，收音是从这边哦。
天哪，这些人太吵。Hello?
Hello.
Hello? Can you hear me?
Yes. Yes.
但是我听不到他。Do you mind speak a few words? We are now doing audio testing.
Speak a few words. Yes.
Because we can't hear you.
You cannot hear me?
等一下。
4个全要特殊的水壶，然后还有大家桌上看到的，是不是很可爱的瓶子，对不对？那这都是从小学的实验室直接拿出来的。那我们先用展示考虑一下。然后住在小学旁边的呢，是我们的杨女，然后她今天下午跟我们分 了很多关于声音、海底生物收音的部分。那这些的话，我们等一下他应该也会有想要玩玩看我们的 Corqui， 它会有非常巧妙的声音表现。
刚刚有像
那再来的话，我介绍一下是我们的卫生，还是我们的 WATERIA 的艺术家，然后我们是声音表演的艺术家，然后等一下呢，可以一起听一下这个 Corqui 光的声音怎么样表现。
And now?
这边然后那接下来呢，等一下我们会把时间交给然后也请他介绍一下
上屏 projector。
英文的方式介绍。
对不起。
大家不用紧张，因为刚才我
对，应该是那个，应该是那个。
支援 Andrew。
那麦克风我收。
你刚刚是的那个指示吗？
音讯输出，刚是从音响出来的。
接下来，首先会有半个小时的时间，
因为麦克风，我没有麦克风。
可是我刚点这个，然后就
没有在输出，所以它从后面出去。你测试它从后面出去，
所以这样是对的。
代表这个应该是对的。哦。
Hello, Jose, can you hear us?
Yeah.
Yes. Thank you.
我也不想碰，最混浊的是草皮才可以碰，我们都不能碰，会伤伤。那这个是大家一定都可以碰的，它就是来自 Sealand 的水，很简单。那其他就是草皮从草踏或者是大园采回来的，有受到一点污染的水。那这边的话也可以做大的测试的一个样本。好，那我们等一下就交给Jose喽。
She just finished the introduction.
Okay.
So you may start. Thank you.
Yeah, super.
Okay, you can introduce yourself and the workshop. Yeah, start. Thanks.
Super. Thanks, Vanessa, for the introduction. Hi, my name is Jose Quiroga, and I'm talking to you from Spain. I was invited. Well, I want to thank first of all Julia Xiang for the invitation to participate in this WATERIA workstation of the Lapilla proposal. And I'm a little bit worried because it was supposed for me to be there right now with you and to spend all the week working in this reef area, in the Aga area. And well, I'm here in Spain because of these restrictions for the COVID pandemics and so on. So thank you, Julia. Thanks to all the team for assembling this. Thank you especially to Andrew, that is the one in charge of making this fantastic documentation you have with you on the tables. To build this device we're going to be building today. I'm part of an organization that is called INBEC, that stands for in Spanish, but stands for the Institution for the Monitoring and Surveilling of Contaminated Areas. And I don't know how to translate it, community investigation, right? So what we do mainly at the INBEC project is three things. First of all, what we have is a learning program that is online, and it's a learning program for communities affected by contaminating processes. What we do is to teach the use of environmental tools, affordable, easy-to-use tools to communities affected by contaminating processes of all kinds, from a huge landfill to a waste incineration facility, And what we do with this program is basically to empower these communities, and then we go hand with hand with them. We make a accompaniment to carry on their investigations. What we develop is this easy-to-use and affordable methods for environmental investigation from a forensic point of view. What we try is to assemble a dossier with these communities that in the events of the local authorities do not do what they should do in relation to these contamination processes, they can compose a dossier, a tiny beginning of investigation that can then go to the authorities and show them and push them to act. Understand? If anyone has questions during this session, that's going to be 2 hours, please ask me and interrupt me. Don't be afraid of it. Okay. What we're going to do in this 2-hour session is basically I'm going to talk a little bit about citizen science. That is a concept I don't like really much, and I'll explain why. And then we will build this Corqui device. That is a tiny circuit that will let us check the conductivity of a liquid. And the difference with another conductivity sensors is that we won't get numeric value, but we will get sound value. So I'll begin, if you want, with this tiny introduction to citizen science that maybe all of you know more or less what is it about, and why we from the INVEC refuse a little bit this concept. Yeah, I don't know, Vanessa, if maybe then, because I was told that Andrew would present a little bit the documentation he made for building the Corqui. I don't know if he wants to do it now or maybe later, or I can go.
Yes, we can go now.
Okay, fantastic, fantastic. So my formation and my colleagues in the INVEC project is we come from the documentary audiovisual investigation realm, and we approached the scientific tools after a big investigation in a huge landfill in south of Spain. There's these populations that are affected by gases produced by this installation in Orihuela, it's called the place. And we managed, working with the community, to get to trials, to the judiciary area, and we reached to close the landfill, to stop the activities of this big landfill that was for 20 years accumulating a lot of trash from the region. And what we did, what we found after the victory on trial was that the trash was still there, and the process of dismantling this landfill was a never-ending process, and with political implications and economic implications, because there were several ways to dismantle this landfill. Several companies got into the area to get this contract, and the process is prolonged in time. So what we found was that the gases were still being emitted, and the populations were still being affected by this, in theory, closed and non-operating landfill anymore, but what didn't mean that the area was clean or habitable. And we began with the development of an Arduino-based device that was called Leptos, and to get affordable tool around $100, $200 that would be monitoring the gas emission, methane, propane, and all these deadly gases that are produced in this kind of installations. So we were working for a year in the development of this device using these cheap sensors, Arduino-based or Arduino-focused sensors that are all around $15, $20. I mean, they are really, really cheap, but what we found was that they were not accurate. Understand? We were working with gases, lethal gases, and you cannot have a toy. I mean, you cannot go to the affected communities with a device that is not served. I mean, it's not going to be useful for their struggle or for knowing if the levels of these deadly gases is critical or not critical. I mean, if you have a methane rate in the air that is X, is big and is deadly, I mean, the solution is not putting a mask or not closing the windows. The solution is taking all the population out of the place. So we were not confident in this Leptos device. So we discontinued it. And basically what we are working is in tools that are really useful for the communities. I mean, we are not interested in engineering. I mean, we love Arduino, we love open source and hardware, and that's our baseline for work. That all has to be open and free in the sense of freedom, right? You cannot go to a community and say, okay, we have this device that you can use for measuring or monitoring methane emissions in your area, and that is not accurate tool, right? So we are focused in this kind of methods and tools because a lot of time when we talk about science investigation or science-related investigation or investigation that uses scientific tools, we're focused in accuracy and so on, right? So and accuracy and most of the time people think that it involves a lot of technology, and that's not true. I mean, investigation begins with the observation with our sensors. We have a full equipped body that has sensors that we can use to monitor an area, to monitor a place, right? And we try to downgrade technology in that sense, correct? In a moment where megapixels and high wideband, the communication is always growing and growing, and data transmission is on the rise. We think we need to downgrade to go to the core and to let people, I mean, to do things widely spread, right? So, in a sense, when I said we don't feel comfortable with the concept of citizen science, is because citizen science most of the times is related to, I mean, there are a lot of models, and there's citizen science means a lot of things and puts together different practices and different methods and projects that are really, really, really different. So what we don't like in IMBEC about citizen science is, first of all, the term citizen, because it's an exclusional term. I mean, citizen defines itself as concept from the exclusion. If you are a citizen, there's someone that is not citizen and is not belonging to that place. So first of all, this, for a political reasons, the term citizen science is something we don't like to use, even though we are inside the citizen science realm, correct? But I'd like to address this from the beginning, right? From a decolonial perspective, the term citizen, at least in Europe, is defined by the exclusion of the non-European, and that's something we don't like in IMBEC, okay? Second, because there's this, I mean, community term is what we prefer to use, community science, because it's made from the base to from bottom to top. I mean, bottom top oriented, and there are several kinds of projects, and a lot of them in the citizen science world are academic projects that use the citizens or the communities just to collect data, right? There are projects that are not related to the problems of the territory, or they approach territories with contaminating processes ongoing because they need a manpower. They need people who collects data, right? We prefer, I mean, we are interested, and it's not that we are preferred, we're interested in collective processes that begin from the affected population, because affected population is the one that is going to, I mean, there's the who's suffering the effects of these contaminating processes, and because people from the ground know the place, I mean, know how the thing works, I mean, know that maybe if they close that landfill, they won't be able to eat because that the landfill is the only work source in the area. I mean, I would just to go back a little bit to the first thing I was talking about, the landfill. What we found is people was really reluctant to set that up because they wanted the landfill to still work. I mean, we were doing an investigation with the people there, and in the end, even though they are dying and they know these gases are killing their children and so on, and it's the only source of work in the area. So in that sense, there are a lot of projects that go into that areas and don't, I mean, they're not responsible for the outcome of that investigation, that most of the times are bad for the affected population. It's a dilemma. I know that I'm maybe throwing stones to my roof, but yeah, I think we think that it's important to be at the service or to work with with the affected populations, but not lead the processes, right? And the communities must lead the processes because they are affected, and they're going to stay living there for decades, as they have been doing, right? Yeah, so in that sense, citizen science is this concept we refuse. There are several types of projects, collection projects, there are conservation projects, there are virtual projects that you just put your computer at the service of a project. I don't know if this project that is analyzing sounds from the outside space and use computers all around the world, and when the screensaver of your computer starts, you connect to this project and analyze data. So yeah, basically what I would like to address is, again, a little bit going back, but for us it's important, is that one of the cons of the contrast or the negative aspects of citizen science is that not all the devices we use are calibrated or accurate. So this is a problem. Today we want to be building not a scientific device. We're going to build a device that can be used for several things, but not for checking if something is polluted. But yeah, it's scientific related, but it's not scientific or accurate, and so on, right? Not all the questions can be addressed by citizen science, because it's also this, I don't know how to say this in English, but the discussion about citizen science value, if the citizen science can substitute the science made with really accurate devices, with budgets and precision and accuracy. But I don't think the debate about citizen science or citizen science must be kept as something that has to fight with science, correct? I think they're complementary, and there are a lot of processes that we can, I mean, this educational or this engineering session we have today is something that can make make the community stronger. And I think maybe you don't know among all the people here there today, but if we do this in a community that is affected by contaminated river water, so on, this can be a moment to get in touch, to know each other, and that's basic for resisting contaminating processes from our perspective, right? So this is one of the pros of the citizen science activities, the community engagement. Community engagement and data collected by communities make communities more aware of the situation and or bad situation they're going through, right? One of the scopes of the INBEC and the tools we develop is that the tools must be useful and can be used by transgenerational people, right? From a grandmother with her granddaughter together can get data or can investigate their surroundings, right? And the technology today allows people to report from a lot of using a lot of formats and real-time reporting and so on. So there are a lot of projects that you can report a contaminating event in your area in real time and do it to all the world, right? So basically, what we try to do in INBEC is to focus in the use of scientific tools as a forensic policeman. Do you know this CSI TV American series that is crime scene investigation? And these are policemen that are investigating crimes, and they're using scientific tools, but as one of the tools, as tools in their toolbox, right? They use a lot of tools, and we need to use them to obtain certain data that is important for the investigations. And when we talk about contamination, we're talking about pollution and chemicals and analysis. You can think that something is contaminating, but if you don't know the composition of that thing, it's difficult to convince someone that the pollution is happening there. So yeah, we come from the documentary realm, audiovisual one, and we have incorporated these scientific tools as a camera or as an audio recorder or as a complement to our eyes and noses, right? So when we approach an area that is contaminated, we understand that our word as community has not the same weight in trial as a government official. I mean, if some government official goes to a place and takes some pictures, and then these pictures go to trial, these pictures will have more proof value than our pictures, because of the fact that this is a government official. And even using the same camera, even going with him, his photos would have more weight in a procedural sense, right? So we are working with reverting or inverting the concept of reasonable doubt. Maybe you've heard this in the films, that no one can be sentenced in a trial if there is a reasonable doubt that this person didn't commit the crime, correct? If there's one reason and is not absolutely certain that this person committed the crime, cannot be sentenced. We use this and give and put it upside down. What does it mean to reasonable doubt? To work with the concept of reasonable doubt, as we are not certified witnesses as a government official. The methods we use are not accurate, so accurate as the government officials' tools used by government officials. We try to collect enough data to generate a reasonable doubt that something is happening in that place. If we collect water from the river and be regularly taking pictures when the water comes down with a lot of foam or with weird colors. I live in a place where there's a highly contaminated river 200 meters from here, and sometimes it's red, sometimes it's purplish. I mean, it's different colors and dense water and so on. I mean, maybe you don't. We are not government officials, but we can get enough data and send that to analyze to a laboratory, these water samples, and get these. We can go from undefinite, I think the river is contaminated, to a situation in which we have several analyses in time of these waters, and we can say there is arsenic, there is any contaminant element in the water. So we go from an undefinition to a definition, even though we are not, for fifth time, I say, we are not certified witnesses like a government official. We can assemble a dossier enough strong or enough solid to push the local authorities to begin a proper, regular, official investigation. We're interested in changing politics and changing the situation. We're not interested in scientific tools as an engineering or as a science by science, because of the knowledge must be spread. We think these tools must be useful for the defense of the territories affected and the defense of the people affected in those territories for contaminating processes. So I'd like to show you, as I cannot be there, the idea was during this week to approach this algae reef that is under threat in the area. And there will be some activities around during this Kill Lab. I hope you enjoy them. I wish I could be there. And we have assembled a website that is called Registro, that in Spanish, a registro is a register. It's a place useful to get, to record things, to get an historic record of whatever. You can register photographs or bad odor events or whatever. And we would be doing two main activities in the reef. One of those was to map the area using aerial photography. When we talk about useful, affordable, easy to use tools, we mean this. In an area where drones are all time lowering their prices. I mean, you can get a drone now really cheap compared to 5 years ago, but you need a lot of formation in the thing. You need to know how to fly it, and how to fly it is like flying an airplane. I mean, you need flight hours. I mean, you need to fly, and to be to masterize the drone flying to take pictures of an algae reef with wind and so on is not so easy. It's not like flying in your house with your tiny drone. You have to have parts to repair your drone. I mean, you have to have a drone, a good drone that can handle a good camera and fly with it. And so there are lots of things you need to know. You need to know about electronics. You need to know about flying. What we use to make aerial photography is taking pictures using kites and balloons, captive balloons. We use big captive 1.5 meter balloons to put cameras in the air. I think Everything's going good, right? Yeah, because I'm talking too much and I have some things here. I didn't see if everything's okay. So what we do is basically use this kite photography mainly. In the case of the area, would be done kites because there's wind and so on. And the equipment to do this kind of photography is under $100. One good kite, professional big kite with a GoPro-like camera, is under the $100. In one season of 2 hours, in one session, sorry, not season, any one of the present in this room would be doing aerial photography by its own. I mean, it's not so difficult. You need good wind. If there's no wind, you use the balloon, and it's even easier. Yeah, and it's really cheap. If you have a bad landing, the worst thing that can happen is that you have to saw a little bit the kite or replace the camera. But this kind of cameras is under $50, and the same with the kite. If you have a bad landing with a drone, maybe you break a motor, you break the whole drone. I mean, you can lose all the equipment, and a basic equipment for aerial photography with drones is around $500. So with the price of one drone, you can buy 5 equipments for aerial monitoring. It's not a technique we have developed at the INVEC project. It's a technique that has as many years as photography. Aerial photography with zeppelins and kites was done during the Second World War and so on. And yeah, I mean, it's as long as photography. Kiting has 3,000 years in the human history, and kite combined with a camera was as many years as the cameras. So yeah, and these last years, this has been really developed and pushed by the public lab community. It's something I want to talk. We are part of this multinational community that stands around the publiclab.org. All the links and things that we've been talking will be in this video at the part of the YouTube video recording, so don't worry. But the publiclab.org, the public lab community is a community oriented to develop the same thing: affordable tools for scientific investigation, and is basically it was founded during the BP oil spill in the Mexican Gulf 10 years ago. There was a lockdown by the authorities, and no drones could be flown. So people from the public lab, especially Jeff Warren, began to take these kind of pictures from boats. They went to the sea and they put these balloons and kites in the air. You fly the kite through 300 meters. So you put a really high camera on air and taking pictures with an auto shoot, auto trigger position. You can get you can map the area and take a lot of pictures from a zenithal perspective, and then you assemble them. You grab 5, 6, 10 of those pictures, and you can make a tiny map from a mid-height. Yeah, and that was one of the activities we were going to do during this lab kill lab. The other one was to extract different layers of ground. Water is contaminated.
Live streaming
is on. Water is when water is contaminated. In the case of a river, for example, water is flowing again all the time. So we can grab samples of water and analyze them. But there's the water today, not the water tomorrow, or the same water of 1 month from today. But contaminating elements go down, sediment in the river, right? So what we do is to extract with a tiny tube, a PVC tube, plastic tube, and a shovel and a big hammer. We extract this. These like what they do in the North Pole. They put this cylinder that goes down, grabs the ice, take the ice out, and they can date the different layers and detect different components in different times of the life of that ice. The same with mud or sludge. I mean, the ground is not only a technique for river or water contamination, can be used in every type of soil, but we use it in relation to rivers. So I would like to show you this English.registro. That is a web page. Oop, 1 second. Copy link. I'll try to show my screen right now, and just for you to see the web page, and I'll be finishing all these chapa, what we said chapa in Spanish, that is talking and talking and talking. I will begin to put hands on the device. Let's see. Yeah, there it is. You can go to the web page in English.registro. This is a web page built with a really lightweight web content management system, CMS. It's called Pico CMS, and it's really fast because we understand that not all around the world the internet connection is the same, and a lot of times web pages are really heavyweight, and people in several places cannot access to them, or can access really slowly, or at a cost of too many data transmission. So it's a very simple web page where you can find manuals and methods to investigate contamination around your area. These were the two we were going to do. I was talking about the aerial photography and the ground sampling method. You can access all the documents here, and there's the list of materials to do it. I mean, I'm not going to be there, but if someone is interested in taking, in doing these activities there, we can meet in Jitsi and I can explain. But the idea of this webpage is that I don't have to be in the middle. I mean, that anyone can come here, read the documentation, do the analysis and the extraction of the sludges and muds. The same for the aerial photography and so on. So English.registro will be in the YouTube video too. And yeah, I think this is pretty much all about citizen science, or what we call self-defense science. Sorry, I'm going to stop share my screen. Okay. And that's what I wanted to say about this citizen science concept, that is basically people reporting, in few words, citizen science will be that people reporting information to contribute to answer a question using scientific methods or tools. But within that, there's a whole world, and there's this just data collection for an academic project, and there's this approach of self-defense. And yeah, what we think is these scientific tools must be focused in defending the territories and defending the people's health, right? So I'll put also because I want to begin with a workshop, as we don't get with a little time. Even I see there's majority. I mean, there are adults in the room. There's some children, maybe, I don't know, just to understand a little bit the composition. What I see is basically adult people. I saw a tiny person going to the room at the beginning, maybe, I don't know. But okay, just I want to say that I don't want to get too long in this explanation or this talking Chapa. So we can begin with the Corqui. But I wanted to say that just one thing, and I'll put it in the YouTube. Under the YouTube video. There's this project. One thing I was going to carry in my trip to Taiwan was this device that is made with Arduino, and is called Nayad. It's developed by, I'm going to show my screen again. It's developed by a friend that is called Saulo Jax and Valentina. They have their stack of toys made out of Arduino that are scientific or pseudo-scientific, right? And he began to build this device that for me is fantastic, and is maybe the first water monitoring device based in Arduino, Libre, free and open source device that is intended to monitor water, and is the first IC that has calibrated, accurate sensors. I mean, it's not a 100 or 200 euros device. It's a device that full with the 8 sensors that it uses. It's around $700, but it's rock solid. It's distributed, data collected and distributed in several servers around the world. And yeah, I'll show you just I mean, they're in the process of retouching or finishing up the design and doing the PCB more smaller. But yeah, it's something I wanted to share, and I'll share you 1 second. There's the web page, so it keeps on record. It would be this project, the Hacking Ecology project. Sorry, it's in Spanish, English. So yeah, this project is scientific in the sense of, I mean, when we talked before about accuracy, this is an accurate device. The hardware, I'll show you. It's based on Arduino. It's basically an Arduino device that maybe not everybody in the room knows what is it, but it's an open and free hardware device where you can use for touching sensors, actuators. You can make a door for your hands at home, or you can do a water monitoring device. And this is the board that controls everything. And I think there's a picture here. No, I go back. Well, it's basically a cylinder with the hardware inside and the sensors outside. It's distributed, so it's more resilient. If there's an attack on the database, here it is. Yeah, fantastic. Sorry. So this is basically a first prototype. Now they're going to make a crowdfunding. The crowdfunding was going to be before the pandemics. They stopped the thing, and they've been working in doing a better database. They were working in software and the design of the hardware, but the system is working. And I was using this device during this week in Taiwan, but maybe in another time, maybe in the future. So how are you there? You need to do a 5-minute stop to go to the bathroom, take a fast coffee, or we can go on with assembling. Raise your hands, those who need to go out. Raise your hands. No, everything's cool. Okay, no, a good friend of mine recommended me to do this, maybe this 5-minute stop. If no one needs it, we can go on.
Oh, I think we can, yeah.
Cool, super cool. So the Corqui. The Corqui is a frog, and that's the name of the device because, well, in a certain sense, it's like a frog. It's tiny and it's related to water and makes a funny sound. And The Corqui is a device that is really interesting because it doesn't need to have electronic knowledge about. You don't need you don't need a hot iron. You don't need to do complicated things. Just putting wires in a proto board. That now we're going to see what is it. Where is it? And can be done. I've done this workshop with people starting in 10 years, the less it was, and they did it by themselves. Doesn't mean that there were no problems, and there can be problems today. We can put the wire in one hole up or one hole down, and it won't work. But it's really easy to assemble, and it's really cheap. All the materials you got there, I think, are around, depending on your provider, but $6, $7, $4. It depends on the place you buy it, and if you buy a lot of components and so on. So it's a really nice activity to make with kids. You can be a teacher in a school, and you can grab some of this for the whole classroom, and it's not going to be so much money. And what I like to say about the Corqui is it's an activity that starts with science or with a natural area of the curricula, and you can then jump to the music and arts. So you can begin doing this as a scientific purpose and analyzing some water samples and so on, but then you can use it for music, and you can expand it. You can combine several of these devices, and you can use another components and make it more with, I mean, to have more features, I understand. The Corqui was developed by the public lab community, as I was saying before. And the purpose of this is, or what I like, is not the purpose, but what I like most is that contamination sometimes is difficult to see, or even when I say see, is to perceive. It's difficult to perceive. Contamination processes are slow, maybe a lot of times are invisible, and because of that, it's difficult to understand. It's difficult to understand to a boy, to a girl, to a tiny child, because it's strong, and I mean, the time has passed a little, just, no, have not had not the experience to see someone dying of cancer. And with this device, we can hear changes in the composition of a liquid and begin to perceive in a better way what contamination does, that is changing at least the elements of some liquid. So you have with you a fantastic documentation done by Andrew, that I'm not sure if Andrew is in the room or not. I forgot to ask. Yeah, he made these kits you have with you and did a fantastic documentation in Chinese that is really, really beautiful and solid and exhaustive. So all this workshop will be really fast. Fast in the sense that you have all the materials and all the documentation to do it. I'll just guide you, and I'll be doing a Corqui, assembling also a Corqui here with you. So you have these components. Let me see how I begin now. Let me close some tabs here, so my computer stands. Yeah. So I think all of you have the bag with you with the components. Maybe you can, I don't know, you have all outside the bag, and we can go through the materials. I can show you my setup here. Let me turn on. So I go screen stream. Here's my stream, and let me share with you. Sharing. All right, there we are. Let me check. You can see all the screen. Okay, cool. Cool. Full screen. Okay. So what we have is basically, I don't know how many of you have ever done something like that, or use a proto board, that in my case is this red piece. You'll see that my image here is a little bit laggish because I'm using a phone streamed to my computer and then streamed to you in Taiwan, but I think you can see it correctly. What we have is a proto board that the first thing I have to do is to say is that these proto boards, the use of this is, the scope of these proto boards is to do a prototype without having to solder the components that sometimes you don't know if the circuit is this way or that way. So you have this board that the main characteristic is that these holes are connected this way. All right. So if we put an element in this hole, will affect or will be connected to all this line. It's divided in two blocks of rows and columns, and the rows are connected among themselves. I mean, there's a metallic wire underneath these holes, and all of them are connected. So when we connect something to this hole, will be connected to all the holes in this hole. The same, if we connect something here, it will be connecting all the floor here. All right? Vanessa, if there's any doubt or if I go too fast, please just tell me. And now I'm not seeing you because I'm monitoring my camera is working correctly. So maybe I go on with the chapa. And don't mind if you're okay. I can see you now. I did a change. Okay, cool. Okay, so we have this proto board, and then the basic parts of this device are this tiny chip that is called a 555 timer. I'm not going too deep into the elements because we're here to assemble it, and maybe I don't know how interesting it is to go deep in what does every pin of every leg of this device that is has 8 legs, or the composition of the resistor or whatever. But you can check that in the documentation.
Yep. Shall we stop for a little bit, or tell us in Chinese about how to assemble this? Okay.
Cool.
Okay.
You're making kind of tiny translation.
Yeah, maybe 3 to 5 minutes. Okay,
cool.
I'll time to Andrew.
Okay. Super.
Okay.
对，所以你如果要把两根线导动的话，如果我要把这边支撑导动，就是插来，然后这一台是给它的导动，对，然后这个直台呢是这个就是导动，这个导动，对，所以我们这自动一插就导很这样导，对，然后这个直台呢，然后我这个角呢这样子的话，然后我这上面的这个每个洞插入口就代表需要这个点，概念上是这样。然后刚给大家的一个讲义上面的那个左上角有个角度。这个是比较详细的说明，然后你可以看到它的做法跟文件上面，文件上面会有说明，然后也有图片讲，大家手上这个讲义，对，然后分别上比较记得就是，当我们说把那个角位，就是说变成这个东西了，就代表说两个连接在一起，对。然后，反正我要讲的是，你在上面插一点的时候啊，它的直台是中空的，所以你在上面选择任何一个点。
大家了解这个意思吗？了解，直接插上去都是通的。
就是我插到哪里都可以吗？还是一定要知道它的插法？
横排的，对，
直排的，然后直排的到哪里？
我已经有人做完了。然后如果有任何地方
如果任何有问题，或是你不确定的要举手，在你上电之前，一切都有救。只要正负不要接受，就不会有问题。然后跟他讲，跟他说。真的。
Live streaming is on.
要继续吗？
你跟他讲，你要跟他讲一下我在一起。
我会跟他讲一下。Hi, Jose and Vanessa.
Yeah.
Yeah. I'll let Andrew introduce his PowerPoint
介绍器材，他们
Fantastic.
for the materials because
Super.
someone don't know the basic knowledge of the materials.
Super.
So she
Super.
will join us via GC, so you can also read his proposal.
Super cool. You want me to share the documentation so it gets on record, or it's not necessary?
Okay, so he just joined us via
Super.
GC. Yes.
Fantastic. I mute myself so there's no sound here.
Okay.
Super.
会操作了吗？
对，然后你要分享。有了。
可能就是我们，如果先大概快速讲，就是大家手上拿到的材料是这些东西，然后那个其实最重要的是一个补充，就是那个 IC 啊，然后每个那个 IC 的那个另外一边有个缺口，然后那个缺口就是我们会标记 IC 的第一片在这边，对，然后所以如果这个是缺口的话，这个是它是逆时钟方向。就1、2、3、4、5、6、7、8这样，对，然后所以为了统一，就是比较好示范，就大家统一把这个缺口朝向这边，对，然后就是他等下接的时候就会这样讲，就是说我要把4号接到8号的，就像这样子。那大家手上拿到的那个。这一组啊是不光线，它是比较短的。我们等下接线的东西比较短的，然后这个比较长的是拿来做写子弹放的，对，所以这个通常是最后才接。这是切，要切到它的是。对，然后，现场长这样子，对，但是其实有这种现场。然后地方你会看到有一个长这样，应该是咖啡色的，那个是电的，对，咖啡色的，它应该写一个104，代表它是0.188，就不用推管。 然后另外一个小的这个电池，我们拿到的应该是咖啡色的，然后上面会有三个色块，应该是什么？橘黑红，对，
这是什么？这是电子的电脑。
然后另外你们会拿到一个蓝色的，这其实是用来改装用的，这个跟它我们会做一个比较基本的照相，对。然后如果你要改装的话，你可以用这个。那改装的话，时间如果来不及到，这个5天都能做。
Hey, Jose, I'm very sad. It will take a little longer.
Don't worry. For me, it's perfect. I mean, interesting thing is that people here make the device. Don't worry.
Okay, you can just see us.
Yeah. I'm here at your disposal.
Everywhere.
Don't worry.
Yeah, thank you.
Cool. Super cool.
有煮完的人可以来装水哦。
我也不想喝，因为我闻过那个味道。那个化学味很重啊，
现在会怎样？
就是表演历史。有，我都有去过。老乡环境，在我这边。我有的时候我刚跟他聊过。好，自己大吗？我有去过这里。
我没有比较过。我跟你说一点，你再分给别人。现在看谁需要这个？哦，这个。他需 其实不用那么多，就可以分给别人。对，你看这样。我有他们的这种。
没有，我拿第三个，左边手过来第二个。我刚刚需要一个反差高啦。
这个好像你的多了一点。
这个比较厉害，你要叫得大声的话，那这个，因为它其实它那边的化学物质，然后如果你弄到手，你不能去洗手，可能会很痒。对，对，你不知道玩这个吗？只要在打，其实没有小妹，小妹在里面，没关系，让我选择。但是你要换备章，没关系。这个。
不能自己。过滤过的声音就不一样，声音就不一样。如果你看比较冷水，你可能也会紧张。
Hi, Jose, I'm Vanessa.
Yeah?
Yeah, I think most of us successfully made Corqui.
Super, super. Let me stop this screen sharing. So, okay, here I am. Cool,
Yeah.
super cool. Yeah, I was hearing. I thought there were a lot of frogs around there. Rocking.
Do you hear the voice of Corqui?
Yeah, absolutely. The different sounds. Yeah, it's like beep, beep.
Yes.
Super nice, super nice.
And,
Yeah, documentation. Tell me.
Do you want to share more about Corqui, or maybe your exploration about the Corqui?
Yeah, I can, I mean they've done it. I think I saw this photo resistor.
Yeah.
They have used it.
Yes.
And also potentiometer, I think. I can share a little bit of things, but mainly is successful assembling, right?
Yes. It's very easy to assemble this.
I had to do nothing.
No, you did very well.
Cool. I can show my setup here that is a little bit different in the sense that components are different, but yep, as you want, or we can, I mean, if there are questions or comments, or we can do a little bit of talk.
So maybe 10 minutes later, okay, you can show us your different type of Corqui.
Okay, that's good.
And then after that, Andrew will show his another kind of Corqui.
Cool, super cool.
Okay, so that
I think it's more rich or tasty. The Andrew presence there is, they can touch the device. I can show this, but Andrew's is awesome.
Okay.
Cool. So I do it now or in 10 minutes? I didn't understand.
I think maybe at 5 minutes later.
Super, super. Or 10. I'm here. If you want.
I will cue you to introduce another kind of Corqui.
Cool. Super.
Very different. She would just tell you and take care of it.
所以其实比较没有杂质，所以可以拍它。
果装什么是矿泉水之类的，电解水都不一样。Jose, are you ready?
Yes, I'm ready.
You can show your different type of Corqui to everyone. Okay?
Okay, super.
Okay, you can start now.
Yeah?
Yes.
Okay, cool. Okay, so Vanessa just told me that she told me that there were almost all the cookies assembled there, but I was hearing them to talk, right? When you were doing, I began to start hearing all the different cookies there. So mission accomplished. I have to say that again, and I won't be hesitate to do it 100 times, that Andrew Lean documentation is awesome. When I received it, I was really shocked with the clarity and the cleaning of the whole documentation. So thank you again, Andrew. And I'm really glad that you have a document where you can see the schematics. There's this QR image on it, and you have the 9 steps. I think there are 9 now. Maybe I'm wrong, but yeah, you have these 10 steps to assemble the cookie, and in the lower part you have some mods. It's great, Andrew, and thank you for including them, because this is what makes the Corqui a more featured device. There are a lot of hardware projects that are done with this same 555 microchip. You can go on Google or whatever search engine you use and check 555 Teamer projects, and you'll get a lot of links to do another simple devices using this same microchip. So I encourage you to do it because it's really fun. And I just want to talk a little bit about these mods and the possibilities of the Corqui using these different setups. I'm going to show my screen again, or maybe it's not necessary. You have all this document. First of all, there's a photoresistor, as you see. I mean, the basics of the Corqui is this probe of 2 wires that you put into the water. Yeah, that begins the sound, and depending on the conductivity of the water, that has more or less salts inside in it, dissolved, you can get a more high or low sound. So if you put the sample into clean water and you put some salt in it, the sound will go from a low to a high sound, right? So this is interesting. The photoresistor transforms the Corqui in a pseudo theremin. You know this theremin instrument that has two metallic wires, and when you approach your hands, one of those lowers the tone or hikes or puts the tone higher, and the others for the volume. So you can use the photoresistors to approach your hand to the Corqui and modify the sound with it. So it's not continuous sound, right? I'll jump to the mod 3 in the documentation. That for me is the biggest or the most important mod of this. That is the audio jack. You can add to the Corqui. Instead of getting the sound and that's it, when you put your sample inside the water, you can use the audio jack, first of all, to use another bigger headphone or another bigger, headphone, no, to do the sound, to attach it to a hi-fi sound system or to a synthesizer, or you can use this sound produced by the Corqui, produced by the water. You can take it to another instrument and modify it. You can put it into another instrument, or you can stream it to your computer and modify it. You can also record it. I mean, you can have a historical record of the sound of the water of your river, for example. Let me try to explain this with my English. That is not the best in the world. You know, to tune a guitar, there's this tuner, no? This device that when you take one string, you sound one string, or a piano or whatever, and this software says if you are in A, B, in which tone you are in the musical scale, right? Every Corqui is built with different sensors, I mean, with different elements, materially. I mean, the resistor I have here or the resistors you have there, even though are the same quality and the same grade, are not, the materials are not the same. We can have a longer wire or a shorter wire. That will make our devices sound different, even though using the same elements. So, yeah, so the practical exercise to do to have a record would be this. We use the Corqui. Every sensor needs to be calibrated, needs to have a reference. So we can do with Corqui some calibration. We can do a musical calibration, understand? When we start when we power on the Corqui is making a sound. If we use a known conductivity liquid that is used for calibrating this kind of conductivity sensors, not this kind, but conductivity sensors, those are liquids that we know the quantity of salts. So always have the same conductivity. You have there 4 samples of water, or 3 samples. I think there was one that was a little bit stinky and maybe you're not sampling it. But imagine this exercise. We don't have to imagine it. We have this exercise. What we would need is to have this liquid for calibrating conductivity sensors, and would be our 4th sample. So we start turn on the Corqui, use this calibration liquid, and put the samples inside it, and it will generate a sound. The 4th of the modes, no, the 2nd of the mode, sorry, potentiometer. The potentiometer can let us to lower up or lower down a little bit the tone manually. So we can use this guitar tuner application, put the samples inside this known conductivity liquid, and make it sound. And with the potentiometer, approach the sound to one known note, 1 to A, for example. It's almost in A, we can use the potentiometer to set the sound in A note, okay? And that's our calibration. This would be the procedure to do before every single sampling of the water. Once we have this always A, for example, or one of your devices can be closer to a D note. Okay, we use D note, and we put it in D always before analyzing the other liquids. When we have the calibration, the musical calibration of the device, we can go on with the liquids. Clean water, river suspected polluted water, and river absolutely contaminated water, because we know that. And we get these different sounds, but with the calibrated device at the beginning. Okay? Then, once we have this calibration, we can record this sound of the different waters we are analyzing with the, but for that, we need the audio jack. We can record with our phone and going out of the tiny piezoelectric black speaker we have there, but it's better to use the jack and record it with, for example, and you have it in the documentation by Andrew, you can record it with Audacity. That is a free open source software you can download for all the platforms, Linux, Windows, or Mac, and you can have a record. So this would be the exercise with children. If one of you is teacher or is working with or has sons and daughters, you can do this with them and do this periodically. I mean, it's a device that can serve us to keep track of the sound produced by our river. I mean, if you're close to the river, you can go once a month or once every 15 days. You take a sample or go to the river itself and put the Corqui into the water and record before. You need to calibrate with this known conductivity liquid to have always the same, I mean, to begin to a starting point, always the same starting point. We have to say that metallic parts of the device that go into the water tend to oxidate and to degrade. So this is not a device that we can use forever and will always be calibrated and respond the same conductive response. But it is not the scope of this to have a accurate tool, but a tool to approach people to the investigation of environmental aggressions and pollution, and also to open hardware and engineering, right, and electronics. While you were doing the assembling yours, I was following the fantastic documentation by Andrew, and because it's not the same as I did, and he has simplified it, and it's really awesome. And I made my own here. I don't have the exact same parts you have. There's this fourth mode of the Corqui. That's the power switch. I have a power switch that is not staying when it's not packed. I have a pusher, and the pusher just works while I push it. So I'm going to show you a little bit some of my, not concerns, but I'm not an expert in electronics. I studied law when I was young, and I began working in photography, documentary photography and video, and 10 years ago, I mean, this is not, time passes. I'm a 15 years career photographer. My approach to electronics, to science is, as I said at the beginning, from a documentalist that uses another tools that are related to science, but for documenting. I'm not doing science, and my electronics and electrics savvy or knowledge is not so big, and we can solve my doubt about why this is happening. I'm going to change my setup here, and this here. Let me check if everything pairs as it has. Cool. Cool. So what I did was assemble the same Corqui. but instead of using this big piezoelectric speaker, I had one tiny one here. Okay. And this is the only difference, not the only one. I'm powering up the all sound is different because the resistance is different, but when I push it down, well, this is not a super featured musical instrument, but well, you can see that it changes a lot, right, with the setup. I'm going to put again these two first wires, and one thing that happened to me is when I use the potentiometer, so we need to remove this. I'm going to use a different potentiometer. A potentiometer is just a resistance, like this tiny one, but is modular, is variable. We can change the resistance of the resistance of the resistor with this. In my case, I don't know if this resistor is a little bit bad or what, but when I put it in here, and there, no, yeah, it makes this ticky 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 ticky. It is not lowering up or lowering down. Maybe it's for the, yeah, I know what is it. We have there, the sound is really low. When you go up, it's a little bit higher, and then it has an interval. I mean, I don't know if I said it in English, but we have a rhythm there. We have a very fast rhythm or low rhythm, okay? Okay, so what we can do is to combine several of these different setups. You can get a straight sound, you can get a rhythmic sound, you can use a pusher to cut the sound, and you can combine this with another instruments. As you see in the documentation with the jack, for me the jack is the thing. The jack is in the same place of the piezoelectric speaker, and yeah, sends the sound to whatever place we want to put it, right? So this setup with the Corqui, with the 3.5 millimeters jack, is the solution to integrate this wave emitter generator, because what this is doing is generating a wave that has their specifics, and we can use it to be modulated by I don't know if you're familiar with modular synthesizers, analog synthesizers, that you can, with a jack, you can send a signal to another module, do a modification, specific modification there, maybe transforming the wave that is a P into a beep, 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 and that you can send it to another one, modulate it again, and so on. So this is a fantastic device to introduce children to science and to investigation, to registering and recording historical data of their surroundings, and glide into the musical realm or the musical part of the curricula, and yeah, what we call the KICME we're developing is the it was in Spanish, but was the introduction kit to citizen science and electronic music. And yes, I don't know if you have some questions or comments. I would be glad to answer any of those. I have to say thank you because to all the staff, because there's a lot of people there. I think copies have been assembled, and wow, I'm amazed with and I'm very grateful to all the team and all the presence there.
And now Andrew will show his different type of Corqui now.
Please, Andrew, let it rock.
其实这个他刚刚有提到，就是你要控制这个声音呢，其实改变这电子，然后原理就是把它放到水里面的时候，水只会改变，这样声音会改变。对，然后他刚刚有提到一个就是，如果你要调音的话，是这样问题。然后就是因为它改变的是水的电子，所以但是它其实不只是可以用来测水，它也可以用来测光线强度。然后它手上应该会有光谱电子，那它有一个特性就是，当你的光线强弱变化的时候，它就有不同的电子。那这里有一些相当于把它放到水里面，不同的水的电子。所以你要测试的人，你是把这两根线打亮，然后放在这个插电的地方，然后你的手靠近或者离开，它就会有声音的变化。对，差别在于你放到水里面的时候，你放进去还是有声音没声音，但是这个它是程度的变化，就是你这样手让它渐渐从亮变暗，从暗变亮，它就会有声音的变化。然后这个等下你可以做一下，就是其实做起来大概这样，你把这两根打掉，然后把这个放到原本的地方。然后应该就会看它的变化。然后这个是他后来有提到，就是他后面有买一个比较大的那个是比较大的核心电阻，它是用转的。然后我选这个是有它的漂亮的。然后因为它比较麻烦是，它用那个螺丝起子去转它。对。然后使用的方式很简单，就是那个电阻上面会有3根角，然后你只要选2根角。然后我选的是这两个，因为比较跟这比较近，对。然后所以就是我刚刚讲，你把它插到这边的时候，这个线就跟它连在一起，对。然后所以另外这只脚把它接出来，所以它应该是像这样，对。就是原本在这边人拉上去，然后所以这个时候呢，它会有一个现象，就是你转到这个的时候，它就不转的，就是我示范一次。这样，然后，这个是我没有附材料给大家，但是如果你要把这个声音做输出的话，你要去买一个那个是3.5，就是 audio 的接口，然后 audio 接口有2条线，就把它接到那个你放喇叭的地方，对，这2条线原本是放喇叭的地方，就把它拔掉。如果你放的地方，它就会一起响，对，然后你就可以把它接到这边，然后之后你就可以接像这种喇叭，然后它的声音就会从喇叭出去，但是就是有点吵，它会从喇叭出去的，对。然后如果是从喇叭出去的话，你就可以做一些分析，这样。就是他刚有提到我写的那份文件，那份文件里面有一个，他用一个 open source 的软件，就是它可以录音，然后录音的时候你就可以得到它的音轨，对。然后这个有点像是你去听那个声音给你的感觉，这个声音听起来比较干净，听起来比较有污染的，对。可是如果你用一些方式把那些声音做处理变成图像，它可能会是一个看起来比较干净，或者看起来比较脏。对，那这个是大家后续可以自己去研究看，那个我在文件上面都有写这样子。那今天差不多就到这边了。
好，那我们先谢谢 Andrew， 谢谢。然后呢，我们也跟镜头挥手一下，谢谢 Jose。Hi Jose, thank you for joining us. Okay.
Thank you very much.
然后最后有一个忙要请大家帮忙的，就是手上是不是都有一个水杯？就是在你们回去之前，就是请带着这个水杯，跟着 Vivi 去洗水杯。对，跟着 Vivi 拿着水杯，跟着 Vivi 去洗手，还有洗水杯，然后再把水杯拿回来吗？
这边太远了。
好啦，那就放在洗手的地方。
或者是对，就旁边我们俩去收。
好，那就是跟着 Vivi 洗手跟洗水杯，然后水杯放在洗手台就好了。那今天谢谢大家，谢谢。Hi Jose. Hello. I told everyone to wash their bottles.
Super.
Yeah, so our workshop is completely finished.
Super.
Yeah, thank you very much for introducing us the Corqui.
Thank you.
Very interesting. Thank you.
It was my pleasure. Wow, Andrew, super.
Yeah,
Nice.
I think I should take a picture of both of you.
Okay.
这些东西要放回去的。
不用，带回去。对。Okay, I'll take a picture of both of you. Okay, so I'll send the picture in Telegram.
Super.
Yeah, thank you very much.
Thanks, Andrew. Thanks a lot, Vanessa. Thank you very much.
So bye-bye, Andrew.
Bye-bye. Have a nice week, and I hope everything goes cool.
Yeah, sure.
Super.
Bye-bye.
Thank you.
Thank you.
Bye.
Thank you.